If potential energy is alpha minus beta by 2 x square, what is the force acting on the particle? See, let us consider 2 points here, and this is point 1, this is point 2. Energy of the particle in this point, this is a conservative field. In this conservative force field, you consider 2 points. If the particle is here, and at every point the particle will have energy. Let's say at point 1 the particle has energy u1, at point 2 the particle has energy u2. Now the particle is doing work to move from point 1 to point 2. Let's call this position S2 and this position S1. What is the work done by the particle? Work done by the particle is force experienced by the particle into displacement. Displacement is S2 minus S1. If particle does the work, and that is translated in the form of decrease in energy, and whatever energy the particle it has here, using that energy only it is doing work to move from here to here. So the total work done by the particle is force into displacement. If work is done by the particle, then the energy of the particle decreases, and the change in energy of the particle is final energy minus initial energy. And final energy minus initial energy is change in energy. Change in energy is force into displacement, which is delta S. Here the only one thing we need to remember here is if work is done by the particle, energy decreases, and hence this change in energy will be negative. Then force acting on the particle will be negative of change in potential energy by distance, change in position. This position, if in the denominator if you have distance, the whole thing is called a gradient of what? Potential energy. So force experienced by a particle when displacement is infinitesimally small, that's what the differential limit we call, minus delta u by delta s can be written as minus du by ds. Hence, force experienced by a particle is nothing but negative of the potential gradient of the particle. Since here the function is x function, the potential is taking place or the work is done along the x-axis, so it is minus du by dx. Then force experienced by a particle is minus of d by dx of alpha minus beta by 2 into x square. When you multiply minus d by dx of alpha, minus into minus plus d by dx of beta by 2 x square. Hence the differentiation of alpha, which is a constant, 0. Here beta by 2 is a constant, we have to take it out. So beta by 2 into d by dx of x square. But you know that d by dx of x power n is n x power n minus 1. Here it is beta by 2 into d by dx of x square is 2x power 2 minus 1. 2 minus 1 is 1, so it is 2x. So it is beta by 2 into 2x. When you cancel, it is beta times x. Here the force experienced by a particle is beta x, which is our option B.